Hello everyone. In this video, we will see how to find the largest prime factor of a number. So what does this actually mean, guys? Let's say you take a number. Let's say you took 26, okay? So which is the largest prime number that can divide 26? 26 can be divided by many other numbers, but we will consider only the prime numbers, okay? And the largest one. So which one will be the largest prime number? 13 is a prime number that can divide 26, right? And 13 is the highest prime number that can divide 26, okay? So 13 would be the result in this case. If you see the screen and if we run the program, right? So let's say enter a number, we provide 26, okay? So we get 13, okay guys? So let's say if you provide here like 12, okay? So 2 I mean, 3 is the largest prime factor to divide, uh, you know, 12, right? So let's say how it, let's see how it works, okay? So first of all, you know, if you see this screen, okay, so let's say we took a number 36, okay? So 36, we have to divide by 2, okay? We have to start dividing by 2, okay? So we need to know how many times 2 can divide that number, okay? So if you see here, 36 divided by 2, 18, okay? So 18 would be divided by 2 again, 9. 9 divided by 3 is 3, right? Okay? And 3 divided by 3 is 3. So how many, 2's and 3's here, guys? There are two 2's, okay? And two 3's, right? So these are the, factors, okay? For 36, okay? So in this case, 3 is the largest prime, okay, to divide 36. So let's see how it works. So you can see the functions, loops and functions here, guys, and we make comment, okay? So handle factor 2, okay? So we need to know how many times 2 can divide that number. So 36 modulus 2 equals 0 if it's true. If we know the 36 can evenly be divided by 2, okay? So largest factor, we are assuming that 2 is the largest factor, okay? And we are assuming we have declared largest a variable and it holds the value 0, okay? So you know that we already applied this technique in various programs when you count sum or uh, when you do this kind of stuff, okay? So we apply these techniques in many programming problems, guys, okay? So fast iteration, while you see first iteration is true, right? So then will assume largest is 2, and then now we will divide the number by 2 and we will put the result in the n again, okay? You see 36 divided by 2 is 18, okay? So 18 is being stored in the n again. So this is a first iteration, guys. And the second iteration, 18 is the new n, okay? So n, 18 divided modulus 2, so we know that it can evenly divide 18, right? So largest would be 2 here again, and 18 divided by 2 equals 9, okay? In this case it will be 9, guys, okay? So when you consider this third iteration, 9 modulus 2 would be, would not be 0, okay? So it will false, so there is no more iteration, we need to terminate from this while loop, okay? So now we will check for odd prime factors, guys, okay? So we will see uh, how many odd numbers we get, odd prime we get, right? So okay, so in the first iteration I starts from 3. We did these techniques in so many problems, guys, okay? I into I, 9. 9 is less than or equal to 9. Yes, this condition is true. It's equal, not less than, but it's equal, so it's true, guys, okay? So while in this loop, 9 modulus 3, 9 modulus I equals 0. So we know that this condition is true, right? So largest will be I. So here our largest was 2, okay? Because we we didn't increase the value here, guys. We just considered 2 only, okay? But here we will increase the value, right? So this is why we are considering the largest equals I. So 3 is here. So n equals n divided by I. So 9 divided by 3 is 3, right? So now I will be increased, guys. Okay, so when I increases, I would be 3 plus 2. So I hope you understand this one. Okay, so this is I equals I plus 2, guys. So I was 3, 3 plus 2 will be 5. Okay, so 5 into 5, you see here, 5 into 5, 25. I into I means 5 into 5, so it's 25, right? So we are not changing this one. This is the initialization, guys. Okay, so 25 uh, is less than or equal to 9. Okay, so this should be, false condition, right? Because 25 is, uh, far away from 9. Okay, so we can't do anything in the second iteration, right? So we have n as 3, right? 3 is our, n. So now finally we have if statement. If n is greater than 2, okay, so if we know that 3 is greater than 2, then largest would be 3. Okay, guys, so I hope you understand, guys. These things may confuse your eyes because, we're keeping n and beside this 18. So this is just to, make you understand easily, guys. I hope you will, uh, excuse me for this. Okay, so now we will get the largest number, right? So let's consider this for another number. Largest prime factor is, n is 55, right? So, largest is 0. Okay, so handle factor by 2. First iteration, 55 modulus 2 is, false, right? 2 can't evenly divide 55. So largest would be 2. So we can't enter into this while loop, guys. Okay, so we have to jump here and then check for odd prime factors. First, in the first iteration, I starts from 3, and 3 into 3, 9. 9 is less than or equal to 55. This condition is true, right? So now we will enter into here. 55 modulus 3, this is false, guys. 3 can't evenly divide this 55, right? So this should be false. Okay, so now we have a second iteration. Okay, this will be increased, guys. Don't think here is finished. This will be increased. It will be 5. Okay, so 5 into 5, 25, right? So 25 is less than or equal to 55. It's true. So, you know here we will, 55 modulus I, that means 55 modulus 5 equals 0. This is true. So largest would be I is 5, guys. So here 5 is stored in this largest. So n is, n divided by I. So 55 divided by 5 is equal 11, right? So n is 11 now, right? So for the third iteration, 36, I becomes, not 36, it would be 7, guys. Okay, so when it's 7, it would be 49. 7 into 7, 49. So it's fine, guys. It's less than 5. Here it would be 7. So 7 cannot evenly divide, right? So this should be false. So if we take like another iteration, then it would be 9. 9 into 9 would be 81, right? 81. So when it's 81, it's far beyond, 55. So here it would be false. False condition, right, guys? So we can't come into this while loop, right? So we need to erase these things. Okay, okay, so now we have if n is still greater than 2. So what was our n, guys? Our n was 11, right? In the second iteration, our n was 11, and after the second iteration, we couldn't, get any appropriate condition to, get new result, right? For n is 11 now, then we will return 11. So this is what happens, guys. uh, this is the this is how you can get the largest prime factor of any number, right? Okay, now we will get the smallest prime factor, guys. Okay, so smallest prime factor is, let's say how we will do, guys. We need to discuss these things. Okay, so if you take any even number, right, whatever, how much big it is or whatever the bigger number is. Okay, so if it's an even number, then any even number can be divided by 2, right? And 2 would be the smallest prime factor. There is no question about it. Okay, so we will return 2. If it's evenly divided by 2, then we will return 2. Okay, so if it's n is less than or equal to 1, we'll return -1. That means no prime factors for number 1 or less than 1. You understand? So if we can divide by 2, then 2 would be the smallest prime factor, so we will return from here. Okay, so there is when we return from here, we don't need to check the other conditions, right? We don't need to check other things, so we can return from here. So in case of 36, we will return from here. Okay, so 2 would be the smallest prime factor for 36, guys. Okay, so let's say we consider for 55 here again. Okay, so for the smallest one, so this condition will be checked, and this is not, n is not less than 1, so we will go forward. Okay, so if 55 modulus 2, n modulus 2 equals 0, that means we're checking for 2, right? So this condition is false because 2 can't evenly divide 55. So this would be false, and we will go forward. We don't enter into this if statement. So now we will check for odd factors. Okay. So in the first iteration, I starts from 3, I into I, that means 9. Okay. So 9 is equal or less than n. You understand? So when 9 is, this condition would be true, guys. Okay. So when this is true, 55 modulus I divide, I mean, that means 3. So 55 modulus 3 is false because 3 can't evenly divide. Okay, so if the first condition was true but this is false, so we can't enter into this, we can't do anything here. For the second iteration, check odd factors. I will be increased by 2, right? So we didn't change the initialization is still 3, but we will increase here. So 5 into 5 means 25. 25 is less than or equal to 55, it's true. So 5 can divide 55. Okay, so return I means 5. Okay, so for second iteration we get 5. Okay, so now we will return 5, guys. Okay, so in case of smallest factor, if any number can divide, okay, so if any number can divide that number, any prime number can divide that number, this will be the smallest. You understand? If 2 can divide, then 2 is the smallest. If 3 can divide, 3 is the smallest. You understand? And we don't have any chance to go forward because we are returning the value from wherever we get. Do you understand? I hope you understand. If you don't understand, uh, type the code on your own, okay, and visualize the code for any other numbers. Thank you for watching, guys. See you in the next video.